welcome back to this Forge College Explainer. So, if you survived our last session, testing and debugging Borsh integration, hey, you've already done the heavy lifting. You've battled those byte mismatches, wrestled with the serializers, and successfully debugged your integrations. Honestly, give yourself a well-deserved pat on the back. But we aren't quite finished just yet. Today is literally all about the final launch inspection. We've got all the pieces of our Solana program, and now it's time to assemble them into this cohesive, undeniable masterpiece that proves your Borsh-backed data flows work perfectly, end to end.
Okay, let's dive right into this. Here's our engineering blueprint for today. We're going to start with a final assembly and recap, take a close look at the capstone acceptance criteria, and walk through the 3 build phases. Then we'll map out our files, hit that verification checkpoint, and finally, cross the finish line by submitting your project.
Section 1, Final Assembly and Recap, why we are here. Let's move on. Think of this whole process like building a high-performance sports car. You know, a perfect engine is completely useless if the steering wheel falls off the second you hand it over to a reviewer. So to pass this capstone, you absolutely need a submission-ready repository. Now, what does that actually mean? Well, it's not just about code that happens to compile. It's a fully functioning program with integrated Borsh serialization, fully equipped with repeatable tests, crystal clear documentation, and, this is absolutely crucial, deterministic reproduction steps. That word deterministic is going to be your best friend here. It basically means your instructor can pull your code down, run your commands, and get the exact same results you did, without having to guess, hack around, or decipher any cryptic clues. Section 2. Capstone acceptance criteria, the rubric. So the crucial point here is knowing exactly how you're going to be graded. We really don't want any surprises here, right? So let's look at the 5 non-negotiable criteria. First up, the program builds cleanly without any warnings. No sweeping errors under the rug. Second, your main flows have to execute without runtime errors. We need to see that initialize, update, and read cycle working totally smoothly. Third, your serialization round-trip tests, they need to pass perfectly. Fourth, your integration tests must pass, proving those multi-instruction scenarios actually work on-chain. And finally, number 5, your repository documentation is completely filled out. That means a clear README, solid build stems, and usage examples. If these 5 pillars are standing strong, you've successfully proven your Borsh integration.
Section 3. The 3 build phases, the assembly line.
To hit those rigorous criteria we just talked about, we're going to use a highly structured engineering assembly line. This removes the emotion, removes the guesswork, and makes sure absolutely nothing gets left behind. So phase 1 is repository and CI sanity. Basically, your digital hygiene. Are your folders where they should be? Are your continuous integration workflows set up to actually run tests automatically? Then we move to phase 2, runtime verification. This is where you run your tests, fire up your local validator, and definitively prove your code doesn't just panic and explode. And lastly, phase 3 is packaging the deliverable. That's where we polish up the documentation so the reviewer experiences a completely flawless run.
Section 4. File and folder map where everything belongs. Let's move along and see how this builds out. Now look, if your repository looks like a messy digital junk drawer, I guarantee you're going to lose points before the instructor even runs a single line of code. Submitting a chaotic folder structure is just a surefire way to frustrate a reviewer. And let's be real, a frustrated reviewer is a strict reviewer. So this exact map right here, this is your golden ticket. You need a program folder for your core source and handlers, which gets verified with your build command. You need a schema file or an equivalent for your canonical Borsh schema definitions. You're also going to need a clearly labeled tests folder for all your unit and integration tests. And finally, an examples folder to hold your demo scripts. Just stick to this exact map and your reviewer will be navigating your project with a smile.
Section 5, the verification checkpoint, the final countdown. All right, we've reached the final countdown. This is essentially the trial by fire for your capstone project, so you really want to run these exact sequences yourself before your instructor does. Step 1 is build verification. They'll run the build and expect 0 warnings. Step 2, unit tests, targeting your library specifically. Step 3, integration tests to verify all those multi-instruction flows. Step 4 is the demo run, where they'll execute your shell script and just watch the magic happen right there in the terminal. And step 5, the documentation check. Now listen, at every single one of these stages, you need to be checking your logs. Keep an eye out for panic traces, deserialization errors, or account size mismatches. Catch them now so your instructor doesn't have to later. Now, what's really interesting about this slide is how it highlights the distinct but equally vital roles of your testing suite. Your unit tests are zooming way, way in. They're asserting byte-level equality. They test completely isolated serialization and deserialization round trips just to ensure Borsh is translating your data into the exact right bytes. But your integration tests, they zoom out. They execute multi-instruction scenarios, testing actual storage, real state transitions, and the whole lifecycle of an account. The takeaway here is that you literally cannot prove Borsh correctness without both halves of this equation. I want you to go ahead and burn this quote into your memory right now. A working program without clear reproduction steps reduces the value of the artifact. Let me just be blunt here. Undocumented code, no matter how brilliant or efficient or cleverly designed it might be, is effectively broken to an outsider. If the reviewer can't reproduce your results just by copying and pasting a command from your README, well, your code might as well not even exist. Make it incredibly easy for people to appreciate your genius.
Section 6. Submitting your project. Crossing the finish line.
Okay, your tests are green, your folders are pristine, and your docs are crystal clear. Let's take that administrative victory lap. Your final action is to create a submission markdown file. In here, you're going to literally map the capstone criteria to the exact commands the reviewer needs to run, and you'll include little expected output snippets. Next, you're going to tag a release branch, something simple like capstone-ready, and push that specific commit hash. Why do this? Because it absolutely guarantees the reviewer tests the exact flawless state that you validated locally. It completely eliminates that dreaded, well, it worked on my machine excuse once and for all. So here's a question to leave you with today. You've mastered the manual assembly of a Solana program using Borsh. You know exactly how the bytes align, you know how the data flows. But how do we scale this when your perfectly structured codebase needs to become a massive Web3 template used by thousands of developers? Well, that is exactly what we're going to tackle in our next lesson on Solana program templates. You have done absolutely incredible work getting to this point. Be sure to visit forge.college to dive deeper into this subject, explore our other Web3 topics, and just continue your overall development journey. This explainer was made by Forge College. Thanks so much for learning with us, and I'll catch you in the next one.